dimensions because many of those dimensions will show up in the catalog. So when we say we have a W12, it means it's a W shape, and the 12 is the nominal depth of the member, which in this case is right here. That's the depth of the member. It's in the picture also. Okay, then you have the next column that says the cross-sectional area. You need the cross-sectional area for many of the calculations, so it goes ahead and calculates it for you. In this case, 7.65 inches squared, if I can read that correctly, whatever the number is. And the graphics is really terrible on this projector, but we'll worry about that. Yeah, you can almost read it there too. Okay, then after the area column, the next two columns are under the overall heading of the depth, and you'll see that there's two sets of column depths. There's a set of in decimals to 3 significant figures, and right next to it for the 12 by 40, it tells you how deep it is in fractions. The intention is that the decimal numbers are used in your calculations, and the fractional numbers are used on drawings. You can tell for this particular example, they're not the same. Okay? So we basically see that the depth is 12.2 inches for the calculations, and it's 12.25 for the drawings, and clearly we know they're not the same. But AISC, all of its numbers that you're supposed to use in calculations in this whole manual will always be to 3 significant figures. Not to a certain number of decimal points, to 3 significant figures. And the reason they do that, besides the fact it takes up less room in the manual to put all these numbers in, it also is consistent with the loads that we're lucky to know to 1 significant figure. Some of the loads in the building code, live loads, are to the nearest 10 pounds per square foot. So it doesn't make sense to give all of these dimensions to 8 significant figures or 6 decimal points just because your calculator computer can do it. So it gives everything to 3 significant figures. After the depth, it gives the web thickness. The web thickness is basically the thickness of the long skinny part in between the 2 flanges. And for this 12 by 40, it tells you that the web thickness is 0.23 inches, which you would dimension on a drawing as 1/4 of an inch. Goes on, gives the flange thickness in both ways and the flange width in both ways. So basically, many of the dimensions that show up next to the section are given 2 different ways depending on whether you're doing calcs or drawings. The right-hand side of that chart, page 1-27, gives you a lot of the calculated section properties, like moments of inertia and radius of gyration that you're going to use in some of your calculations. So to go ahead and calculate all of this stuff out for you, give it to you so you don't have to do the calculations, you just look it up. Okay, I'm going to kind of talk a little bit about loads. Did Dr. Chilapati talk about loads in the structural analysis thing? Did he get into that at all? Did he get into load combinations? Okay, then I'll cover it. Okay, so basically within the building code, which sometimes refers to another document called ASCE 7, there are loads. Dead loads are you pretty well going to calculate based on what everything weighs. You know how much concrete weighs, 150 pounds per cubic foot. The steel weights you have, the W12 by 26, the 26 was how many pounds per foot it weighed. And the live load you would get out of the building code, it depends on the occupancy. 40 pounds per square foot over the whole floor area, a library. Okay, and we kind of distinguish it when we get the load combination. We just give them the different letters. We're going to combine them, and I give you some examples. Some other gravity loads, we have snow.